Hello everyone, let us see security analysis of SCADA system or security control of a SCADA system. The power system are designed to survive all probable contingencies. A contingency is defined as an event that causes one or more important components such as transmission lines, generator and transformer to be unexpectedly removed from service. Survival means the system stabilizes and continues to operate to acceptable voltage and frequency level without loss of load. Operation must deal with the vast number of possible conditions experienced by the system, many of which are not anticipated in planning. Instead of dealing with the impossible task of analyzing all possible system states, security control starts with a specific state. The current state, if executing the real-time network sequence, a postulate state, if executing a steady sequence. The sequence means a sequential execution of programs that perform the following steps. One is determine the state of the system based on either current or postulated condition. Second, process a list of contingencies to determine the consequence of each contingency on the system in its specified state. Third is determine preventive or corrective action for those contingency which represent unacceptable risk. Security control requires topological processing to build network models and uses large-scale AC network analysis to determine system conditions. Then the required applications are grouped as a network subsystem that typically includes the following functions. Come, let's go topology processor. It is process real-time status measurements to determine an electrical connectivity, that means bus model of the power system network. Then state estimator uses real-time status and analog measurements to determine the best estimate of the state of the power system. It uses a redundant set of measurements, calculates voltages, phase angles and power flow for all component in the system and report overload conditions also. Then power flows. Power flows determines the steady state condition of the power system network for a specified generation and load pattern. Calculates voltage, phase angles and flows across the entire system. Third one is contingency analysis. Assesses the impact of a set of contingency on the state of the power system and identifies potentially harmful contingency that cause operating limit violations. Optimal power flow is recommends controller actions to optimize a specified object's function such as system operating cost or losses. It will be subject to a set of power system operating constraints. Security enhancement is recommends corrective control action to be taken to an existing or potential overload in the system while ensuring minimum operational cost. Then preventive action recommends control action to be taken in a preventive mode before a contingency occur to preclude an overload situation. If the contingency were to occur, then bus load forecasting uses real-time measurements to adaptively forecast loads for the electrical connectivity, that means bus model of the power system network. Then transmission loss factors determine incremental loss sensitivities for generation unit, calculates the impact on losses if the output of a unit were to be increased by 1 megawatt. Then short circuit analysis determines fault current for single phase and three phase fault for fault location across the entire power system network. This is various operating states. It consists normal state, alert or emergency, restorativity. Okay, this means normal state is a system is said to be normal if both load and operating constraints are satisfied. It is one in which the total demand on the system is met by satisfying all the operating constraints. Alert state, a normal state of the system said to be in alert state if one or more of the postulated contingency state consists of the constraints limit violated when the system security level falls below a certain level or the probability of disturbances increases. The system may be in alert state. Yes, the system may be in alert state. All equalities and inequalities are satisfied, but on the event of a disturbance, the system may not have all the inequality constraints satisfied. If severe disturbance occurs, the system will push into the emergency state. To bring back the system to secure state, preventive control action is carried out. Third one is emergency state. The system is said to be in emergency state if one or more operating constraints are violated, but the load constraints is satisfied. In this state, the equality constraints are uncharged. Then the system will return to the normal or alert state by means of corrective action, disconnection of faulted section or loading sharing. Then extremis state, when the system is in emergency, if no proper corrective action is taken in time, then it goes to either emergency state or extremis state. In this regard, neither the load or nor the operating constraints is satisfied. This result is isolating also. The generating units are strained beyond their capacity, so emergency control action is done to bring back the system state either to the emergency state or normal state. Then restorative state, from this state the system may be brought back either to alert state or secure state. The latter is the slow process. Hence, in certain cases, first the system is brought back to alert state and then to the secure state. This is done using restorative control action. These all are in references for following this state analysis or state control system of SCADA. It's very important in SCADA controlling system. Most preferable topic of this supervisory control and data acquisition system of power system because it has to be survival all probable contingency. So this topic is very important topic. Thank you.